Hi to everyone, welcome to NCC channel. My name is Naresh, chemistry lecturer. Today I would like to discuss one of the topic from SBLOC elements, that is solubility of substances. Solubility of substances. In this video, we can discuss solubility of sulfates, solubility of carbonates, and solubility of hydroxides and solubility of hydrates. Solubility. Already you know that solubility is inversely proportional to lattice energy and directly proportional to hydration energy. Here, what is meant by lattice energy? So, lattice energy means the amount of energy required to break the ions in 1 mole of ionic compound. For example, I have taken sodium chloride. Sodium chloride means it contains Na plus and Cl minus. To break these ions, it needs some amount of energy. That energy is called lattice energy. Lattice energy means the amount of energy required to break the ions is called lattice energy. Now coming to hydration energy, the amount of energy released when 1 mole of ions combines with water molecules, that is called hydration energy. For example, I have taken lithium ion. It can attract. I have taken lithium ion. It can attract water molecules. Around its ion. H2O, 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 H2O. So that means why does lithium ion can attract the water molecules around its ion? Because lithium is the positive charge. In water molecule, oxygen is the central atom. It contains lone pairs, 2 lone pairs. So lone pair nothing but negative charge. That's why lithium can attract the water molecules around its ion. So in this process, it releases some amount of energy. That energy is called hydration energy. And if the size of the cation increases, for example, I have taken cesium. If the size of the cation increases, so hydration energy decreases. So because effective nuclear charge decreases and it cannot attract the water molecules effectively. That's why if the size of the cation increases, hydration energy decreases. Now coming to solubility of sulfates. Beryllium sulfate, magnesium sulfate, calcium sulfate, strontium sulfate, barium sulfate. These blue colors indicates the size of sulfate ion. It is the bigger size because it contains 1 sulfur atom and 4 oxygen atom. That's why it is the bigger size. This blue color indicates the size of sulfate ions. Now these pink colors indicates the size of beryllium, magnesium, calcium, strontium, barium. Now when you observe the first molecule, coming to first molecule, here the size difference is more. If the size difference is more, we can break the ions with less amount of energy. That means lattice energy is less. Now coming down, the size difference decreases. If the size difference is less or approximately equal, or if the two ions are equal size, now in that time a strong force of attraction exists between these two ions. If the strong force of attraction exists between these two ions, to break these two ions, it takes more amount of energy. So that's why lattice energy is more. Now when we are moving from top to bottom, size difference decreases and lattice energy increases. So already you know that if the lattice energy increases, solubility decreases. Now the solubility order is BSO4 as more soluble, next followed by MgSO4, followed by CSO4, followed by SrSO4. Last one, barium sulfate, is least soluble because lattice energy is more. Beryllium sulfate is more soluble because lattice energy is less. If the lattice energy is less, it can dissociate easily and can dissolve in water easily. These ions can dissolve in water easily, that's why solubility is more. Now coming to solubility of carbonates. Beryllium carbonate, magnesium carbonate, calcium carbonate, strontium carbonate, barium carbonate. So these are the carbonates. Now this blue color indicates the size of carbonate ions. This blue color indicates the size of carbonate ions. So these are also bigger sizes because it contains one carbon atom and three oxygen atoms. Now coming to these pink color indicate the size of beryllium, magnesium, calcium, strontium, barium. Here the size difference also more. In first molecule the size difference is more. When we are moving down, the size difference is less. If the size difference is less, there exists a strong force of attraction between these two ions, and there is need more amount of energy. That's why it needs more amount of lattice energy. If the lattice energy is more, solubility is less. Here size difference is more, that's why it needs less amount of lattice energy. Lattice energy is less. Size difference decreases, lattice energy increases. If the lattice energy increases, solubility decreases. So the solubility order is BeCO3, MgCO3, CaCO3, SrCO3, and barium carbonate. So this is the order of solubility. So beryllium carbonate has more soluble, and the least solubility barium carbonate is the least soluble because lattice energy is more. Now coming to solubility of hydroxides. Lithium hydroxide, sodium hydroxide, potassium hydroxide, rubidium hydroxide, cesium hydroxide. Now this blue color circles indicates hydroxide, the size of hydroxide ion. These are the small sizes because hydroxide contains just oxygen 8 and hydrogen 9, total 10 electrons. That's why these are small sizes. And the pink color indicates the size of lithium, sodium, potassium, rubidium, cesium. Now when we are moving down, the size difference is more. If the size difference is more, so lattice energy is less. If the lattice energy is less, solubility is more. When we are moving down, so lattice energy decreases. That's why solubility increases. Now the order is solubility order is cesium hydroxide, rubidium hydroxide, potassium hydroxide, sodium hydroxide, and lithium hydroxide. The more solubility is cesium hydroxide and the least solubility is lithium hydroxide. Next coming to solubility of hydrates. Hydrogen is just one electron. It has a small size. So this blue color indicates the size of hydrogen, hydrate ion, and this pink color indicates the size of lithium, sodium, potassium, rubidium, cesium. When we are moving down, the size increasing. Now in last molecule, when we are moving down, the size difference increases. Observe this, the size difference increases in moving down. Here cesium hydride has more size difference. That means it has if the size difference is more, lattice energy is less. If the lattice energy is less, solubility is more. When we are moving down from top to bottom, lattice energy decreases and the solubility increases. Now the solubility order is CSH, RBH, KH, NaH, LiH. This is the solubility order. In this way we can explain the solubility order. Thanks to all for watching my video.